Here now, let us discuss about sight distance for vertical curves. So at the end of this lesson, you should be able to classify the profile of vertical curve, either sag or summit curve, and solve problems using the provided formula and condition in summit curve and sag curve. So let us now start. Okay, so when the convexity of the two grades is upwards, it is referred as summit curve. And when the convexity of the two grades is downwards, it is referred as sag curve. In practice, we should make sure that the transition between these two grades is smooth and safe. And the use of vertical curves on parabolic curves, the use of parabolic curves in vertical curves were found to be excellent in providing riding comfort. And another design considerations in laying out vertical curves is the sight distance requirements. So on our figure, it is the one denoted as S. So the length of the sight distance should be sufficient to ease the shock due to the change in gradient. So that's what we are going to solve here. So here's our formulas. So in summit curve, when L is greater than S, our formula is L equals AS squared all over 200 times the quantity squared of H sub 1 plus the square of H sub 2, the quantity squared. And when L is less than S, our formula is L equals to S minus 200 times the quantity squared of H sub 1 plus square of H sub 2, the quantity squared, all over A. So L is the length of the summit curve, S is the sight distance, H sub 1 is the height of the driver's eye, H sub 2 is the height of object, A is the algebraic difference in grades, and if H sub 1 and H sub 2 are not given, H sub 1 would be 1.143 meters and H sub 2 is equal to 0.15 meters. And then for sag curve, if L is greater than S, our formula is L equals A S squared all over H plus S tangent beta. And then if L is less than S, L equals 2S minus 200 times the quantity H plus S tangent beta all over A is our formula. So L is the length of the sag curve, S is sight distance, H is the headlight height, beta is the angle of light beam, A is the algebraic difference in grades. And then if H and beta are not given, here would be our formula. L is equal to AS squared over 122 plus 3.5S if L is greater than S, and then if it's less than, our formula would be L equals 2S minus 122 plus 3.5S over A. So just memorize those formulas and let's start solving some problems. Okay, so here's for our first problem. So pause it to read. So on the first sentence that was mentioned, we have two grades, positive 3.2%, and then it intersects another grade which is negative 2.8%. So from those grades, positive, pataas, and then negative, so it means pababa, so therefore we are considering here a summit curve. So with the following given, the design velocity is 80 kph, the height of the driver's eye 1.7 meters, the height of the object 1.1 meters, the perception time 0.75 seconds, and the coefficient of friction is 0.15. So first requirement, let us solve for the sight distance. So our formula for stopping sight distance is S equals Vt plus V squared all over 2g times the quantity F plus g. So let us just substitute the values, and then we need to solve for the value of S, which is the sight distance. So for V, we have 80 kph. So let us convert that into meters per second by just dividing it to 3.6. And then for t, the perception time, it's 0.75 seconds. And then g, that's 9.81. And then the coefficient of friction, which is F, it's 0.15. And then for G, which is grades, so we have two grades, positive 3.2% and negative 2.8% grade. So take note that we will just going to choose yung 3.2% grade. So we're considering from G1, the grade 1, and G2. So that 3.2% in decimals is equal to 0.032. Okay, so now let us just solve. So the value of S, the stopping sight distance, is equal to 154.96 meters. So now let us solve for the second requirement, which is to find the length of the parabolic curve. So if we go back doon sa formulas for summit curve, we have two. We have a formula when L is greater than S, and we have a formula when L is less than S. So our solution process here is to make first an assumptions. So if we assume that L is less than S, we are going to use the formula designated to it. And when our assumption is correct, then therefore that would be the answer. And if not, then therefore we need to utilize the other formula. So let us try first when L is less than S. So let us write first, assume L is less than S, and therefore our formula is L equals to S minus 200 times the quantity square root of h sub 1 plus h sub 2, the quantity squared all over A. So let us just substitute the given values. So for S, the value is 154.96. And then for h sub 1, it's 1.7. That's the the height of the driver's eye. And then for h sub 2, the height of the object, it's 1.1. And then for A, that's the algebraic difference of the grades. So we have the absolute value of 3.2% minus negative 2.8%. So let us just compute. L would be equal to 125.42 meters. So that's not yet our final answer. We need to confirm it in our assumption. So we have assumed that L is less than S. So if we look at the value of L, it's 125.42. And then for the value of S, it's 154.96. So now we can confirm that L is really less than S because L is just 125.42, and then S is greater, having a value na 154.96. So therefore, our assumption is correct. So again, once our assumptions is not satisfied, then therefore, we need to utilize the other formula.